Good morning. So our next lesson is on section 1.2, and our objective for this lesson is to use the order of operations to evaluate expressions. So the order of operations, which you've probably learned at some point prior to Algebra 1, is established to evaluate an expression involving more than one operation. So there's generally four steps. The first step is to evaluate any expressions that are inside with grouping symbols. So usually we say this first step here is parentheses, and that's what that P is standing for. The grouping symbols could also be brackets or other forms of grouping symbols, but anything inside grouping symbols must be done first. And if there's multiple sets of grouping symbols, whatever's inside is done first, and then you work your way out. The second step is to evaluate powers, or I would also refer to the E as exponents. So that would be your second step. So your first step is parentheses, and your second step is exponents. Then step 3, multiply and divide from left to right. So it's a little confusing at times because there's two letters there. So sometimes people think that all the multiplication needs to be done before all of the division, but that's not necessarily true. They're basically the same step, but you have to go in order from left to right. And then the same thing happens for our fourth step, which is addition and subtraction. Again, it doesn't matter if you're adding or subtracting first, but what matters is that you're doing those in order from left to right as you come across them. So let's take a look at this example. So this one does not have any grouping symbols or parentheses, so I don't have to worry about step 1. So moving on to step 2, which is my exponents. So I have two pieces here that have exponents. I have 4 squared, which is 16, and I also have 6 squared, which is 36. I still have this multiplication of 5 and this subtraction sign here. Now I'm going to move into any multiplication and division that I have in my problem, but going from left to right. So 16 times 5 is going to be 80, and then 80 minus 36 is 44, and that would be my answer using order of operations to evaluate that expression. So now we have some practice problems, which I would suggest you pause the video, do them on your own, and then just play it again to check your answers. So first thing in all of these, we are not using any grouping symbols just yet. So first thing we're going to do is just focus on the exponents in each of these examples. So number 1, 3 to the second power is 9. Then I only have addition and subtraction left, so I'm going to go from left to right. 20 minus 9 is 11. 11 plus 2 is 13. In number 2, I'm going to do my exponent first. 2 to the third power is 8. Now I have multiplication and division left, but remember, it's just going from left to right. It happens that my multiplication comes first. 5 times 8 is 40. 40 divided by 6 is a decimal of 6.67. You actually do get 6.666 repeating, so if you wrote it as a fraction, it would be 6 and 2/3. So either of those answers would be okay. Technically, if you want to do 40 divided by 6 and just simplify it to 20 over 3, that would also suffice. Now moving on to number 3, we have no grouping symbols. We also don't have anything in exponent form. So we're just going to go right to our multiplication division in order from left to right. So 4 times 6 is 24. And then the 21 divided by 3 is going to give me 7. But I still have that subtraction sign in the middle that I have to take care of. So 24 minus 7 is going to be 17. All right, so moving along. Number 4, 4 squared is my exponent there, which is 16, and 20 minus 16 is 4. In number 5, my exponent is 3 squared, which equals 9. So now I'm going to do my multiplication step. 2 times 9 is 18. 18 plus 4 to finish it up with my addition there is 22. Number 6, 2 to the third power is 8. Now I'm going to do my division. 32 divided by 8 is 4. And 4 plus 6, finishing up with my addition, is 10. And the last three here, I have an exponent in this problem. So I'm going to start with 6 squared, which is 36. Now I just have addition and subtraction left, so I'm going from left to right, adding those up first. I have 51, and 51 minus 4 leaves me with 47. In number 8, I have my exponent of 3 squared, which equals 9. Now I need to do my division. 27 divided by 9 is 3, and finish it up with my addition. 3 plus 6 is 9. Then our last problem here, we have the 4 squared as my exponent. So 4 squared is 16. Now I have an addition, a division, and a multiplication. So the addition is going to wait till the end. I'm going to start with my division because that comes first when I go left to right. So 12 divided by 3 is 4. Now I'm going to do that multiplication. 4 times 16 is 64. And now I can finish it up with my addition, and I have 70. So the next example we're going to do is continuing with the order of operations. However, this time we have some grouping symbols. So if you look in example A, I have this one set of grouping symbols here, the 9 plus 12, which of course that is going to happen first. 9 plus 12 is 21. Now I have the 21 in parentheses, but there's nothing else to do to the 21 in the parentheses. So now I'm just using multiplication or division. 2 with the parentheses and the 21 there, that indicates multiplication. So that would come next. And then we would finish it up with that subtraction, and we would get 5. Now, if you look at example B, there's 2 sets of grouping symbols. We have the parentheses here, which are those curved grouping symbols with the 13 minus 8 inside. And then we have a second set of grouping symbols. These are known as brackets. They're just kind of like a squared off version. The purpose of the 2 different types is so you know which one goes with which, and you always work from the inside out. So the 13 minus 8 is going to be done first. And the 13 minus 8 is going to give me 5. So now I've basically eliminated those parentheses on the inside because I've evaluated that portion. So now I'm left with these brackets or these other grouping symbols, and I'm going to do my exponent first. When you're working with multiple things inside grouping symbols, you always go in order of operations. That's why we did the parentheses first. Now we're doing our exponent, which is an 8, finishing up inside those grouping symbols, 8 plus 3. And then finally, I'm finishing out with some multiplication. And 6 times 13 is 78. So double check. Okay. So now we're going to practice some with grouping symbols. So take a look at our first 3 here. I only have a simple grouping symbol here for number 10. 14 minus 5 is 9. 3 times 9 is 27. In the next set of grouping symbols, within the grouping symbol, I have a subtraction, but I also have an exponent that needs to be taken care of first. So 9 minus, just so happens it's just a 1. Then I'm going to finish my grouping symbol part. 9 minus 1 is 8, and now I have my multiplication. 6 times 8 is 48. Now number 12, I have 2 separate grouping symbols, so those can both be kind of done at the same time. 7 plus 5, which is 12, and 8 plus 4, which is 12. And then when I subtract those, I just end up with 0. All right, number 13, I have grouping symbols, and within my grouping symbols, I have an exponent. So I'm going to have to do that part first. 3 to the 3rd power is 27. Finishing up what's inside my grouping symbols, 27 minus 6 is 21. And now dividing 21 by 3, I get 7. For number 14, my grouping symbols here, 2 plus 8 is going to give me 10. My exponent, 4 squared, is 16. And then when I multiply 16 and 10, I have 160. Number 15, 2 sets of grouping symbols. So working with the inside there, right? So we have these brackets. So within the brackets, we're doing PEMDAS, right? So we're going to do that 2 plus 3 first, which is 5. Now we do that division. And now our grouping symbols really are not there anymore. There's nothing to do inside. And 9 times 3 is 27. And finishing up the last 3 examples here. 4 minus 3. Sorry, 4 minus 1 is equal to 3. 24 divided by 3 is 8. Then in number 17, I have these parentheses, but within those parentheses, I have an exponent that needs to be done first. So 6 plus 25. The 6 plus 25 is 31, and then I'm subtracting that, and I get 17. And then my last problem here, within my brackets, I'm going to do my PEMDAS inside as well. So 32 divided by 8. 32 divided by 8 is 4, and 3 times 4 is 12. So there's one more type of example we're going to go over, and this is going to kind of combine the evaluating of expressions that we did in the last lesson and using our order of operations from this lesson. So you'll notice here it says evaluate this expression when y equals 3. So the first thing you do anytime you have a problem where you're substituting something in like that is substitute it in everywhere it needs to go. So we're substituting that 3 in 2 separate places. So we're going to substitute it in for the y in the numerator up here, and we're also going to do it in on the bottom here. Now, I put the 3 in parentheses when it was next to the 4 because I know that needs to be multiplied. If you want to put it around the 3 on the bottom too, it can never hurt to put the parentheses. Now, when you have a problem set up as a fraction, you're doing your order of operations separately for the numerator, then separately for the denominator, and the very last thing you'll do is simplify that fraction. So it's like having 2 separate problems in one. So doing the numerator, 4 times 3 is 12. And then 12 times 8 is going to simplify to 20. On the bottom, I just have my 2 plus 3, which is 5. So I end up with 20 over 5. Now, 20 over 5 is a fraction that can be simplified because it actually divides evenly. So 20 divided by 5 would simplify all the way to 4. If it didn't divide evenly, then you would just either leave it as a mixed number or an improper fraction in simplified form. So let's try some evaluating. So the first few problems, we're just going to use W equals 9 for all 6 of these. So for number 19, again, I'm going to use parentheses every single time I substitute a number in to evaluate. Now I have to do my multiplication first here. So instead of seeing the multiplication sign, I see 3 and the 9 with the parentheses. That tells me that's multiplication. 3 times 9 is 27. Now, since I'm subtracting a larger number from a smaller number, that just means my answer is going to be a negative 10. For number 20, I'm substituting in my 9 for W. Notice I put it in those parentheses. 9 to the second power, or 9 times 9 is 81. And now I'm subtracting 81 minus 13, which I believe is 68. Now, number 21 is another one like we had in the example. I'm going to substitute my 9 for the W on the top. I'm also going to substitute it for the 9 on the denominator, simplifying the numerator all on its own. 5 times 9 is 45. On the bottom, I have a 15, and then that reduces or simplifies to a 3. Okay, number 22, I'm still substituting in the 9 here. Now, sometimes people get a little confused if they put parentheses in another parenthesis, but 13 minus 9 is just going to leave me with 4, and 7 times 4 is 28. For number 23, still using this 9 for our W. 9 squared is 81. And now I have to do 2 times 81, which is 162. And I believe that's going to be 147. All right, number 24, I have 5 times 9 minus 1/3 times 9. Okay, so 5 times 9 is 45. That's pretty straightforward. Now, if you're doing 1/3 times 9, sometimes people get confused. If you think about this, what's 1/3 of 9? Same thing as 9 divided by 3, right? So if you're multiplying your fractions, this could reduce, and you have 3 over 1. So don't overthink it. 1/3 of something, that just means you're dividing by 3. And then we subtract, and we get 42. Okay, so our last 3 problems, we're still evaluating here, but we're going to evaluate by substituting in specific given values. So in number 25, we're substituting in a 3 for our x's. So we have 1 on the top, and then we also have 1 on the bottom. So 10 times 3 is 30 in the numerator. And then on the bottom, I have to do those grouping symbols first, which gives me a 5. And I end up with 30 over 10. This can be simplified down to a 3. Okay, number 26, this time I'm substituting in an 8. So 12 minus 8 minus 1. I'm just going to go left to right doing my subtraction. 12 minus 8 is 4, and 4 minus 1 is 3. And then finally, for number 27, I have an 8. I'm going to substitute in my 8 for the y in both the numerator and the denominator. On the top, 10 times 8 is 80, and 80 plus 1 is 81. And on the bottom, I just have a 9. And then, of course, this one also happens to divide evenly to simplify down to a 9. And that's it for our lesson today.